Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 2 and our topic is on the techniques of integration, that is T method. We are going to look at the second form of integral under the T method of substitution. And our integral is a case where the integrand is 1 over a plus b sine x plus c cos x. Integrate that with respect to x. Now, if you look at this second form of the integrals under this substitution method, with the previous one, the first one that we looked at previously, we realize that in the denominator now, we have sine x, but it is not squared. Similarly, we have cosine x, which is not squared. In the other case, we had sine squared x and cosine squared x. So when you have this kind of integral, what are you supposed to do? So this is what you're supposed to do. You say let t be equal to tan x over 2. Take note, let me write 2 properly. This is 2, it's not clear. It should be 2. So we are saying t is equals to tan x over 2. Is now clear. I can also bracket it. Take note that when we have sine and cosine in the denominator and they are not squared, then the x you divide by 2 so that we talk of tan x over 2. But in case one, sine was squared and also cosine was squared. And so we are saying let t be equal to tan x. So notice the difference between the two cases. So now we need to find the derivative of t with respect to x. So you write dt over dx. When you differentiate tan, you get sec squared. Sec squared, that is of x over 2, then times derivative of x over 2, which is 1 over 2. So, but you know sec squared can also be written as 1 plus tan squared. So this can be written as 1 over 2 into 1 plus tan squared of x over 2. And you know tan x over 2 is t, so we want tan squared of x over 2, so we square that, that will be t squared. So this thing can now be written as 1 over 2 times 1 plus t squared. So I want to make dx the subject. So you can say therefore, in this case, our dx will be equal to 2 dt over 1 plus t squared. That is if you cross multiply and make dx the subject. So that is another substitution, because I told you once you make a substitution, you must also know the corresponding differential. So we are going to substitute this one that I've ticked and also this other one, those two. Now, we also need to know what is sine x in terms of t and what is cos x in terms of t. Already we have found the x in terms of t. So as we are substituting, we must know what is sine x and what is cos x. So we are going to get those using t is equals to tan x over 2. The easiest way is to draw a triangle. Draw a triangle, or of course right angle triangle. This one, our theta, our angle theta, in this case is x over 2. Our angle is x over 2. We put it there, x over 2. So remember, tan x over 2 is equals to t. T can be written as t over 1, so that we know the opposite and adjacent, because tan is opposite over adjacent. So the opposite will be t, adjacent is 1. So using Pythagoras theorem, I can get the hypotenuse. Remember, hypotenuse squared is the same as the base squared plus the height squared. So that will give us, now we want hypotenuse, you take the square root on both sides. So that will give us 1 square root of 1 plus t squared. Now, from our triangle, it is now easy to get sine x over 2. We can read it straight away from the triangle that sine x over 2. Remember SOHCAHTOA, that is opposite over hypotenuse. So opposite is t, hypotenuse is the square root of 1 plus t squared. I also need cos x over 2. Cos x over 2 from that triangle is adjacent, which is 1, over hypotenuse, which is the square root of 1 plus t squared. So now that we know sine x over 2 and cos x over 2, are we able to find sine x and cos x? Yes, we are going to use trigonometric identities. So you can write this, that sine x can be written as sine of, let me use a different color, x over 2 plus x over 2. Sine x over 2 plus x over 2. Remember, I want us to take note. I'll write it up here. Let me use a different color for the note. Remember here that we can write NB. We know that sine A plus B is the same as sine A cos B plus cos A sine B. That's an identity. Another one, we also know that cosine of A plus B is the same as cos A cos B minus sine A sine B. So these identities are very important for us. They are very, very important. So this note is very important. We are going to use these two identities. One of them will help us expand sine x over 2 plus x over 2. So let's use the first identity to expand sine x over 2 plus x over 2. So what do we get? That will give us, I'll write here equal to, so remember it is sine A cos B, so that will give us sine x over 2 cos x over 2, then plus cos x over 2 times sine x over 2. This is simply the same as twice sine x over 2 times cos x over 2. And we know sine x over 2 and cos x over 2. When you multiply, this is the same as twice. Sine x over 2 was t over the square root of 1 plus t squared. And cos x over 2, we got 1 over the square root of 1 plus t squared. So when you work out that, you get 2t in the numerator, and denominator you get 1 plus t squared. So that is sine x in terms of t. So you can just say sine x should now give us 2t in the numerator and 1 plus t squared in the denominator. So similarly, Let us see how to find cos x in terms of t. You want to express cos x in terms of t. So what you do, you break it down into x over 2. Of course, cosine of x over 2 plus another x over 2. So let me write. We'll write similarly. We need cos x. How can we write this? This is the same as writing cos x over 2 plus x over 2. And when you use identity number 2, let me take it. The first one was for sine a plus b. If you use the identity for cosine a plus b, this will give us cos x over 2 times cos another x over 2 minus sine x over 2 times another sine x over 2. And so you can say this is the same as cosine squared of x over 2 minus sine squared of x over 2. And if I substitute the expressions in terms of t, we are going to get, for the cosine, we got 1 over the square root of 1 plus t squared. And the all of this one should be squared. Then minus, for the sine, we got t over the root of 1 plus t squared. Again, the all of this should be squared. So when you work out that, that will give us 1 over 1 plus t squared minus t squared over 1 plus t squared. And when you combine this under the common LCM, we get 1 minus t squared over 1 plus t squared. So therefore we can say that cos x is the same as 1 minus t squared over 1 plus t squared. That is cos x in terms of t. I will also bracket this because we need to use it. Remember, when it comes to solving or simply evaluating an integral, then you don't have to do the same derivation. All you need to know is the substitution that you're supposed to make. So what is useful for us here is how will we substitute cos x and how do you substitute sin x? So you master this for sin x, master the other one for cos x, and you also need to take note of the dx, which we have written here, and also the t, which is equal to tan x over 2. So the 4 that I have ticked, those are the most important expressions or equations that we need. So those are the substitutions. Whenever you have such kind of integrals, then you make those substitutions. So let me give you an example to illustrate this concept better. And we'll just look at one example, because once we have solved one, then it will be very easy for you to solve the other examples. And in this case, we are going to solve, let me write, or maybe I can do 2 examples so that one will be part A, another one will be part B. Now let me write the questions down. You are told examples. You are told to evaluate the following integrals. In part A, we have the integral of 1 over 5 plus 4 cos x dx. So what do we need? We need to know the substitution for dx and also cos x, because we want to express the integrand as a function of t. So we start by saying let t be equal to tan x over 2. So with this substitution, we have shown that dx will be equal to 2 dt, everything over 1 plus t squared. We have also shown that cos x will give us 1 minus t squared over 1 plus t squared. So when you make those substitutions, let's see the denominator. Denominator, what will we have? I can use a different color. Let me use green. So I want 5 plus 4 cos x. What will this give us? It is 5 plus 4. Cos x is the same as 1 minus t squared over 1 plus t squared. So if I take the LCM, it will be 1 plus t squared. So that here we'll have 5 into, remember 5 is the same as 5 over 1. So that the LCM is 1 plus t squared. So 1 will go into 1 plus t squared, that is 1 plus t squared times, then you multiply by 5, we'll have 1 plus t squared, 5 times 1 plus t squared. Then I can see there's a plus 4. 1 plus t squared will go into the LCM 1 times, then 1 times that one, we get 1 minus t squared. And if you look at the numerator, if I open the bracket in the numerator, we'll be having 5 plus 5t squared plus 4 minus 4t squared. So that will give us 9. Remember, 5t squared minus 4t squared gives us plus t squared. Everything over 1 plus t squared. So that is the denominator. Now we want the reciprocal. So now we are saying 1 over 5 plus 4 cos x. What will it give us? It will give us 1 plus t squared over 9 plus t squared. So that's what you need to integrate now. So our integral will now become, this integral will now be the integral of 1 plus t squared over 9 plus t squared, and dx is the same as 2 dt over 1 plus t squared. So look at our integrals. This one will cancel with this. Let me simplify. So these two will cancel, so that we remain with the integral of 2 over 9 plus t squared dt. That's what we remain with. Now, how do you evaluate such kind of integrals? Where in the denominator, of course, numerator is a constant, and denominator we have a constant squared plus a variable squared. So in this case, you are going to make another substitution, trigonometric substitution. We are going to say that let t be equal to 3 tan theta. We already discussed this previously, why it must be tan theta. So take note of this other substitution. See, we have this is the second substitution. We started by saying let t be equal to tan x over 2. Now we are making another one where t is equals to 3 tan theta. So with that substitution, what will be the corresponding differential? What will be dt? So when you differentiate dt with respect to theta, it will give you 3 sec squared theta d theta. Remember, it is dt d theta. So that when you cross multiply, you get 3 sec squared theta d thetas. Or simply make dt the subject. So let me substitute that into our integral. I can choose another color. So it is this integral that we are solving. We're evaluating, I mean. So this will be, you see, 2 is a constant. or this can be written as the integral of 2 over 9 plus t squared, that will be 9 tan squared theta, times dt, which is the same as 3 sec squared theta d theta. And this integral can be simplified further so that we have it as this. If I simplify, I get the integral. Of course, numerator, you can see the 6 sec squared theta d theta. Denominator, I can see there's 9 outside into 1 plus tan squared theta. So, what is 1 plus tan squared theta? We said that the same as sec squared theta. So those two will cancel. So it's like we have 6 over 9 times the integral of the theta. And 6 over 9 is the same as 3 will go there twice, 2 over 3. When you integrate, you get 2 over 3 integral of 1 d theta. And that will give you, this will give you 2 over 3 theta plus a constant c. Now that is our answer. And we need to replace theta. So go back. We are performing what is called back substitution. We start with this one, make theta the subject. That means theta, from here it is clear that theta is equals to tan inverse of t over 3. That's what we substitute. So it means our answer will be equal to, 2 over 3 tan inverse of t over 3 plus a constant c. But what is t? So you go back to the other substitution where we said t is equals to tan x over 2. So let us replace that. Instead of t, we are going to use tan x over 2. So this can also be written as 2 over 3 tan inverse of 1 over 3 times tan x over 2, and this is added to c. So you see how easy this integral looks like. If you are given any other problem similar to what we have here, then you do the same thing. So maybe I can give you one you try at your own time. You can try this integral. Let me write it down. We call it part B. Part B, you are given the integral of 1 over 3 sin x and then plus 4 cos x dx. So you see here now you are going to make a substitution for dx. You need to replace dx. You're going to replace this. You also need to know what is cos x and what is sin x in terms of t. So, and we have already given you, let me just write them here. The hint is better to work with the hint. You start by saying let t be equal to tan x over 2. So with this substitution, you'll get dx to be equal to 2 dt over 1 plus t squared. We also need to know what is sin x. Because sin x, we got it up there, that sin x is equals to, it was t over 1 plus t squared. not t, but 2t in the numerator. So that was 2t over 1 plus t squared. And where there is cos x, you need to write 1 minus t squared over 1 plus t squared. So you need to make those substitutions and then simplify, check whether you are able to find the corresponding, or simply to be able to integrate the corresponding integrand that is a function of t. Now it is a function of x, but when you substitute these three, you are going to get the new integrand which depends on t. So when you try that at your own time, it is very easy. Your answer, compare with this one. Our answer, you need to get, let me write it down. Your answer should be equal to 1 over 5 ln or ln of 2 tan x over 2. 2 tan x over 2 plus 1, everything over tan x over 2 minus 2. Tan x over 2 minus 2. Then plus a constant c. So go check. You see, when we talk of the t method of substitution, you realize even after substituting and expressing your integrand as a function of t, you also need to use another substitution. So depending on what you get as the resulting integrand, which depends on t, will guide you on the second substitution that you need to make. Like you see in part A, we have made the second substitution, which is trigonometric substitution. Here you will see the resulting integrand, and that will guide you on which substitution you're supposed to make. So this marks the end of this class. Thank you all for watching. Don't forget to subscribe to my channel. Also, don't forget to share, to like, and also to comment the videos in that channel. Bye-bye.